Introducing implicit differentiation. Very good. For implicit differentiation, I'm going to start by writing the example and then introducing the formula. The example says, suppose you have the following relation, x cubed plus y cubed equals to 6xy. Find the derivative of y, or find the derivative of y with respect to x. This is what we're trying to find. When you have a combination of variables x and y's, you can apply the formula for implicit differentiation. This formula says, well, suppose you have a relation between x and y. Let f of x and y is also a function of x, so we're going to write it as y of x, or f of x, equal to 0. Be a relation between x and y. In that case, to find the derivative of y, or the derivative of y with respect to x, we're going to follow the formula minus partial derivative of f with respect to x divided by partial derivative of f with respect to y. This is implicit differentiation. You have a combination of variables x and y. If you can isolate your y on one side, then feel free to go ahead and just take the derivative. If not, you're going to apply the implicit differentiation here. We're going to say that, hey, since x cubed plus y cubed minus 6xy equal to 0 is a combination of x and y. Also, y is not isolated on one side. We apply the implicit differentiation formula. Very good. So y prime is equal to minus, don't forget to put the minus sign here, f of x, partial derivative of f with respect to x, it's going to be 3x squared. This is going to be 0 minus 6y. Divided by f of y, taking the partial derivative with respect to y. X is a constant, so you're left with 3y squared minus 6x. We can distribute this negative sign to the numerator or to the denominator, and y prime becomes 3x squared minus 6y divided by 6x minus 3y squared. This is your final answer. The rate of change of y with respect to x. With respect to x. If you flip this, you find the rate of change of x with respect to y. So let me write this guy down here for you. If I ask you to find x prime or x of y, it is negative f of y over f of x. So if somebody asks you to find the rate of change of x with respect to y, you're just going to flip this fraction here.